it this week. It's your big quiz, which is going to be the thing that affects your grade the most this quarter. Also, you won't have as many grades this quarter because of all the testing starting in April, actually. You have your first EOC already in April. I forgot that you actually do the...
Writing and reading.
Is it, which one is in April, though?
It's both, writing and reading.
No, one's in May, they said. I just got an email on it. One of those is in April, one's in April. Regardless, we start in April. So you're going to have a lot of EOCs and you're going to be missing a lot of this class. So your number of grades will be lower, which means they all are going to count a lot more. They're going to make up a bigger part of your final grade. So when you take that big exit ticket, I hope you're ready. There won't be a whole lot of catching up after that. You'll have probably 2 or 3 exit tickets is all after it. So here's your quick review. Those of you that were not here, we're only going to review one rule, but we learned, well, not really learned, we reviewed a little bit about exponents. Because you all learned about exponents in middle school, whether you remember it or not. When we have exponents, there are some terminology, some vocabulary we need to remember. What is this guy here called, the 6? What was that called? The base. I referred to it as the big number a lot when we first started. I'm not going to do that anymore. I'm just going to say base. So you need to understand this part of a number is the base, and then what's this guy? The 3. That's the exponent. The little guy raised up above the base is the exponent. So here's your first note if you were not here, or if you were here and you want to write it again. Never, ever, ever multiply the base times the exponent. There's no situation where you would do that. None. That's not what the exponent is telling you. What does the exponent tell us?
Times the base by itself.
Yeah, we take the base times itself. I'm going to get rid of that. So we are going to take the base times itself, however many times we have in the exponent. So for that particular term or number, it would be 6 times 6 times 6. And I'm never going to ask you to multiply stuff out. They might ask you on some worksheets, but I'm not going to ask you to do it on any quizzes or exit tickets. So we're just going to learn the rules. Now, we could say then, using this as kind of our model, well, if this means 6 times itself 3 times, this would mean, so then we'd be multiplying it times the 6 raised to the 8. That would mean 6 8 times. So that would be the 8 times. And then it would be that times, and the last term is 6 twice. And then we'd have little multiplications in between. So that's what that problem is really saying. It's just multiplying 6 out a whole bunch. That's all it's doing.
So that's basically what I'm asking.
Well, that's what we're doing. My question was to put this in exponent form. Exponent form means you need to have a base and an exponent as your answer. A lot of people multiplied it out. That wasn't what I was asking you to do. I wasn't asking you to multiply it out. Or they added all the 6s or something different. You need to, what do we do to solve that? What's the first thing you always do when you're dealing with this lesson? Write the base. Write the base, write the base, write the base. The base doesn't change. There will never be a change in the base for any of these rules. Base has to stay the same or else we couldn't use the rules. So I'll also tell you what I'm going to do on one of the, I think it's the big quiz that I do this on. I'm going to test you on whether or not you even know that you have to have the same base. And I'm going to put a different number as the base in some problem. And I'm going to see if you try to still combine the exponents or not. And you can't. You cannot combine the exponents when you have a different base. What else do we have to have in order to apply? This is the product rule. What else do we have to have besides the same base? So there were 2 things for this rule to apply. Same base, and we need to be multiplying the numbers together. So we have multiplication there, multiplication there. That's why it's called the product rule, because we're multiplying numbers together. When that happens, we said, or the rule says, we just add the exponents. So that should have been your next step. You should be showing your work. Meaning write down that you're adding those three exponents. A lot of you just wrote 6 to the 13th, which was correct. But if I give you numbers that are negative and positive and you're getting the math wrong and you haven't shown that you added those numbers together like this, then it's 0. If you show me you're adding those numbers and then you get the math wrong, that's pretty much still an A because you just made a math error. Huge difference between a math error and a process error. So the final answer, I already said it, but if you added all those together, 3 plus 8 plus 2, you got 13. How many 6s are down here? 13. That's all the exponent is telling you. It's telling you how many 6s you're multiplying. That's it. So when we broke it out, we multiplied 3 and then 8 and then 2. So we had 13 6s. That's what this means. 6 times itself 13 times. That's why we add the exponents. We do not multiply the exponents times each other, which some of you did. We add the exponents because it's really just telling us how many 6s we have. We had 3, we had 8, and we had 2, so add all that up, and we had 13 6s. So that's a real super fast review of what we did last week, for those of you that are not here. Any questions on that? I started the recording. Make sure I started the recording. Yep, I did, because it's saying everything. All right, so you have a worksheet that I'm going to pass out. Did anybody grab it, or did I already pass it out? Okay, so I'll pass that out. I'm going to do a few examples like the worksheet first. Actually, tell you what, let's go ahead and take care of the worksheet. Right in everybody's hands. So I'll let you pass some backwards. You should have close to reach. And I'll get one. Oh man, some of them didn't staple. Make sure you have a page that starts with a 1. Yeah, actually now is probably a good time on that. So trade your phone out, please. What? Oh shit. So I will let you.
Not fun in this case.
Back.
You drink more.
Obviously.
I would think you would be so.
I know.
No. Staple.
This is basically the question.
There's some that are similar, yeah. It's not. It's only 4, and there's way more on the papers. All right, so some of these I did just create a problem that's similar to one on the worksheet. So you can use these as a model. So we'll start with the first one. So the first thing I'll mention or show you, these are just multiplication problems. We're just multiplying every number in that problem times the other numbers. Even though we don't see multiplication here, this means multiplying. Just like we said, 2x is 2 times x. 2y is 2 times y. Well, this is 2 to the 3rd times x to the 4th. So I'm going to rewrite it. Oh, and then one more thing. Does anybody have any issues with me making this statement? Are we all good with the fact that multiplication, we can switch the order? If I'm multiplying 2 numbers or 3 or 10, doesn't matter as long as I'm multiplying all of them. I can change it in whatever order I want. 2 times 3 is the same thing as 3 times 2.
In this problem, are we trying to figure out what x is?
No, there's no. Do you see an equal sign in here? We aren't solving anything. It's a good question. Nobody's asked that. I'm glad you asked it for recording. Yeah, there's no solving. We're simplifying is really what we're doing. That's the word you would use. But basically, we're kind of applying exponent rules, which is really the same thing as simplifying. So, I'm going to show you some longer steps. You don't have to do this if you want to for a little while to keep it straighter in your notes or in your head, that's fine. But this problem is really just saying, and I'm going to not combine, but I'm going to move the terms around so they're next to each other. This is really just saying 2 to the third times 2 to the third, just changing the order, times x to the fourth and times x to the fourth. Again, you don't have to do this. I just wanted to show you that we have some bases that are common. What's the base for this thing? It's 2 different bases. You can have 2 different bases. So just to be clear, the base is not 2x. So if you look at this, that is not 2x. So that is not the base. You have a base of 2 and then a base of x. So we can combine within these, we can combine the exponents for the different bases. So we say, okay, well, to combine these bases, what do I do first? Well, what do I do first? What should you say every time I say? Write it, say it again. Keep the base. So I keep the base. Now I add the exponents. Because again, I'm multiplying here, which means I add the exponents down here, as long as I have the same base. Now, separately, I would say, okay, I'm multiplying this. I keep the base, then I add the exponents. Again, because I'm multiplying terms, I can add those exponents together. I don't remember if I said it this class or not. You will never look for multiplication and then multiply in the exponents also. You would also never say that you could add exponents if you have addition here. You can't have the same operation, or else something's wrong. Either you're doing something wrong or you can't apply the rule. So it can't be addition, and it can't be multiplication and multiplication between the bases and between the exponents. So that might prevent you from making a pretty common mistake. If you just have the rules down, then it's not that big a deal. So now my final answer, just kind of combining it all together, is 2 raised to the 6th power, x raised to the 8th power. So there's an example you'll be able to use when you're doing your worksheet. Again, you're just looking for common bases. Now in this one down here, what's our common base? And them. There's only one base. So in this particular problem, you've only got one base. Just the n. But here's what you can still do. If you do not have common bases with your numbers, so 4 and 3 are not the same base. Well, I can still say 4 times 3 because I can still change the order. All that's multiplication. I can flip the order. And I'm going to say, I guess I'll put n. So that's times n to the 4th. And then times. So now I've kind of changed the order around. So my common base is n. I can still multiply the numbers. So just because they don't have the common base, you can always multiply the bases together. You just can't do anything with the exponents. I can't add exponents or anything once I multiply the base together. But I can still multiply the base numbers together and get 12. What do I write for n? Yeah, because remember, don't forget to add in an exponent. There is an exponent of 1 on every number, every variable. So if you're going to combine exponents, you need to look for that. That'll be one of the most common mistakes people make. So I'm going to say 1 plus 4 for now. And then I don't have anything else that I can do anything with the m. So it's just the m squared. So my final answer is that. So that's my final answer. Any questions on that one? So we'll do these two quickly over here, and then I'll just let you get going. And I'll just walk around and help. So what's the first thing I can do on that one up there? Do I have like base? Let's identify a like base first. I'm going to call on some people. I'm going to call on Zoe. I already like bases, Zoe. Look, we're doing the 2m squared times 3m to the 4th. So a like base, like big number. I'll go back down. Could be a variable too. Big number means big variables. Do I have one that's the same? Jasmine, do I have a like base? Do I have a like base? So we're doing this problem up here. Do I have a like base up there? So I hear a no. Everybody agree with that? Yeah, M is a like base. I don't have a like base in the numbers, but the variables can be a base. You can have a base that is a variable. You will have bases that are variable all the time. That is the same base. Now I don't have a like base with the numbers, but I can still multiply that 2 and that 3 together. So I'm going to change the order. And then if we have like bases, we can add the exponents. So my final answer is that. Any questions on that one? So you can use that one as a model. I'm going to have this whole screen up there when you're working. I'll zoom out. All right, so again, look for like bases. I'm going to go with Tristan. Do I have like bases in that problem? What? Yeah, 2. There can be 2. There will be 2. Wow. Oh, you know what? I meant to do something. Where was the one I was going to do it on? So really quickly, I forgot to mention this. This 2 only applies to the M. Does not apply to that N or to the 4. So remember, if there's no parentheses, then the exponent only applies to whatever base is next to it. In order for it to apply to all of the numbers, I would have had to have had it like this. Then that exponent applies to everything. And you'd have to say 4 squared, n squared, and m squared. But if it's only, or if there's no parentheses, the base m is raised to the second power. This is just a 1. And technically the 4 also is just a 1. The 3 you could say is a 1. All those other things have 1s on them. So be careful when there's parentheses or not parentheses as to how you handle the exponents. All right, so back to this. We do have the same bases, but the numbers don't have the same base. But what can we still do with the numbers then? Yeah, still multiply them. They're not the same base. That means we can't add exponents. It doesn't mean we can't multiply the numbers. You can always multiply the base numbers together. I'm going to skip over writing out 5 times 3. So now we would add for the n's, the exponents. You need to know how to add positive and negative integers. For the m's, we would do the same thing. So your final answer you will get some negative exponents. It says only use positive exponents. We haven't learned that lesson yet about how to change something from a negative exponent to a positive exponent. So for now, just leave them as negative, and we'll fix them on Wednesday after we learn how to change a negative exponent to a positive exponent. There's a rule that we have to apply to those. So for today, just combine exponents when you need to, multiply the numbers if you need to. I expect you to be able to do 1 through 10. You shouldn't have any problem finishing 1 through 10 today. Some of them are really simple. So go ahead and get started. I'll walk around. I'm going to go ahead and stop the recording, I guess. I'll leave that up. Let me zoom out and then I'll leave that up. There, that's all 4 of those problems. All right. You need to work when you come back, though, bud.